functions. In this video, we are going to find out the higher order derivative of the given function. If y is function of x, then dy by dx equals to f dash x is called as first order derivative. If we find the derivative of dy by dx with respect to x, then it is called as second order derivative and it is denoted by d2y upon dx square. That is, d2y upon dx square is equal to d by dx of dy by dx. That means second order derivative of y with respect to x is nothing but differentiation of dy by dx with respect to x. Again, if we find out the derivative of d2y upon dx square with respect to x, then it is called as third order derivative and it is denoted by d3y upon dx cube, which means d3y upon dx cube is nothing but derivative of d2y upon dx cube with respect to x. And if we continue the same process till the nth derivative, the nth derivative of y in that case will be denoted by dny upon dx raised to power n. Again, we have certain more notations for the first order, second order, third order derivative, and so on. That means if y is equal to f of x, then the other notations for first order derivative dy by dx, d2y upon dx squared, d3y upon dx cube, and so on, dny upon dxn are y subscript 1, y subscript 2 for second order derivative, y subscript 3 for third order derivative, and so on, y subscript n for nth order derivative. Or first order derivative may also be denoted by y dash, second order derivative may be denoted by y double dash, and third order derivative is denoted by y triple dash, and so on. Nth order derivative is denoted by y raised to power n. Or first order derivative is also denoted by capital dy. Second order derivative is denoted by d2y, where d is capital, so on. Nth derivative is denoted by d raised to power n y. And we have one more notation for the first order, second order derivative, that is f dash x, f double dash x, f triple dash x, and so on. This represents nth derivative of x, nth derivative of f with respect to x. So let's consider certain questions to find out the derivatives more than first order. So question number 1 is find the second order derivative of following with respect to x. The first part is x raised to power 3 plus tan x. Solution. Let y is equal to x raised to power 3 plus tan of x. Differentiate both sides with respect to x. Then dy upon dx is equal to d by dx of x raised to power 3 plus tan of x. Since differentiation distributes over the sum, so the c equals to d by dx of x raised to power 3 plus d by dx of tan of x. Now dy upon dx is equal to x क्यूब की डिफरेंशिएशन क्या हो जाती है 3x स्क्वायर और tan x की डिफरेंशिएशन secant स्क्वायर x. लेकिन हमारा टारगेट क्या है यहाँ पर सेकेंड ऑर्डर डेरिवेटिव फाइंड करना. अभी हमारे पास क्या है dy by dx which is the first order derivative. उसको फिर से हम डिफरेंशिएट करेंगे अगेन डिफरेंशिएट both sides with respect to x, which gives you d by dx of dy upon dx is equal to d by dx of 3x square plus secant square x. d by dx of dy by dx is denoted by d2y upon dx raised to power, which is equal to 3 times d by dx of x square plus d by dx of secant x whole power 2, which is equal to d2y upon dx square, x square की डिफरेंशिएशन 2x plus 2 times secant x raised to power 2 minus 1 into d by dx of secant x. That means d2y upon dx square is equal to 6x plus 2 secant x, और secant x का डिफरेंशिएशन होता है secant x into tan of x. तो hence this is our final answer. d2y upon dx square is equal to 6x plus 2 secant square x into tan of x. तो what we have done, फर्स्ट ऑर्डर डेरिवेटिव निकाला, उसको फिर से डिफरेंशिएट किया, secant स्क्वायर था जिसको हमने secant x का होल स्क्वायर लिखा. अब चेन रूल से 2 times secant x raised to power 2 minus 1 into differentiation of secant x का डिफरेंशिएशन secant x tan x, secant को secant से मल्टीप्लाई किया तो आपके पास क्या आ गया 2 secant square x into tan x, जो हमारा फाइनल आंसर बना. नाउ सेकंड पार्ट, साइन ऑफ log ऑफ x, और हमें इसका सेकंड ऑर्डर डेरिवेटिव फाइंड करना है. तो उसके लिए सॉल्यूशन, लेट y इज इक्वल टू साइन ऑफ log ऑफ x. तो डिफरेंशिएट बोथ साइड्स विद रिस्पेक्ट x, किसके इक्वल हुआ dy अपॉन dx इज इक्वल टू d by dx ऑफ साइन ऑफ log ऑफ x. साइन का डेरिवेटिव cos into d by dx of log of x, which gives you dy upon dx is equal to cos of log of x, और log x की डिफरेंशिएशन होती है 1 by x. तो सिंप्लीफाई होकर क्या बना cos log x upon x. ये हमारे पास आ गया फर्स्ट ऑर्डर डेरिवेटिव. नाउ इसको फिर से डिफरेंशिएट करेंगे विद रिस्पेक्ट टू x. अगेन डिफरेंशिएट बोथ साइड्स विद रिस्पेक्ट टू x, सो दैट हमारे पास सेकेंड ऑर्डर डेरिवेटिव आ जाए. dy upon dx का डिफरेंशिएशन विद रिस्पेक्ट टू x is equal to d by dx of cos of log of x divided by x. लेफ्ट हैंड साइड पे हमारे पास आ जाएगा d2y अपॉन dx स्क्वायर इज इक्वल टू, राइट हैंड साइड पे देखे तो हमारे पास u अपॉन v का फॉर्म, सो यूजिंग क्वेश्चन टूल, so that gives you denominator into derivative of numerator minus numerator into derivative of denominator, which is x upon denominator square. This equals to x cos का differentiation minus sin into d by dx of log of x minus cos of log of x, और x की differentiation आपके पास आ गई 1 upon x raised to power 2, which is equal to minus x into sin of log of x, और log x की differentiation 1 by x minus cos of log of x whole divided by x square. x से x cancel, तो फाइनली आपके पास d2y upon dx square is equal to minus times sine of log of x plus cos of log of x divided by x raised to power 2. चलिए थर्ड पार्ट पे चलते हैं. It is e raised to power x into sine of 5x. Solution. Let y is equal to e raised to power x into sine of 5x. Differentiate both sides with respect to x, which gives you dy upon dx is equal to d by dx of e raised to power x into sine of 5x. अब right hand side पे अगर आप ध्यान दें तो it is product of two functions. So making use of product rule, that is u into v. So that gives you u into differentiation of v plus v into differentiation of u. तो dy upon dx is equal to e raised to power x into sine का differentiation cos into d by dx of internal term, that is 5x, plus sine of 5x into e raised to power x की differentiation e raised to power x. अब अगर इन दोनों टर्म्स पे आप ध्यान दें तो e raised to power x जो है that is a common term, तो उसको हम कॉमन ले सकते हैं. तो हमारे पास dy upon dx किसके इक्वल हो गया? e raised to power x into 5 times cos of 5x plus sin of 5x. ये हमारे पास आया फर्स्ट ऑर्डर डेरिवेटिव. लेकिन हमें सेकेंड ऑर्डर डेरिवेटिव फाइंड करना, तो उसके लिए अगेन डिफरेंशिएट both sides with respect to x, which gives you d by dx of dy upon dx is equal to d by dx of e raised to power x into 5 cos 5x plus sin of 5x. तो लेफ्ट हैंड साइड में हमारे पास आ गया d2y अपॉन dx स्क्वायर. अगर आप राइट हैंड साइड पे ध्यान दें फिर से हमारे पास दो टर्म्स की मल्टीप्लिकेशन है, तो फिर से प्रोडक्ट रूल. So d equals to e raised to power x into d by dx of 5 cos 5x plus sin of 5x plus plus 5 cos 5x plus sin of x into d by dx of e raised to power x, which equals to e raised to power x cos का differentiation minus sin into differentiation of internal term, that equals to 5 plus sin का differentiation cos of 5x into internal term का differentiation 5. तो मैं ब्रैकेट क्लोज कर रहा हूँ प्लस 5 cos 5x plus sin of 5x और e raised to power x की डिफरेंशिएशन e raised to power x. अगर आप इन टर्म्स पे ध्यान दें अगेन e raised to power x कॉमन, तो हमारे पास d2y अपॉन dx स्क्वायर किसकी इक्वल हो जाएगी e raised to power x into minus 25 sin of 5x plus 5 cos of 5x plus 5 cos of 5x plus sin of 5x. Similar terms को add and subtract. Hence d2y upon dx square is equal to e raised to power x 5 cos 5x plus 5 cos 5x, that becomes 10 cos 5x, and minus 25 plus 1, so it becomes minus 24 into cos of 5x. So this is our final answer. तो इसी तरह से हम किसी भी फंक्शन का डबल डेरिवेटिव फाइंड कर सकते हैं. स्टेप्स क्या रहेंगे? जो भी फंक्शन दिया उसको एक बार डिफरेंशिएट करना है, सिंप्लीफाई करना है, फिर से उसको जो भी रिजल्ट आया फर्स्ट डेरिवेटिव में उसको फिर से डिफरेंशिएट करना है. चलिए आगे बढ़ते हैं, कुछ और क्वेश्चंस लेते हैं इस पे. नेक्स्ट क्वेश्चन है, इफ y is equal to sin inverse of x, then show that d2y upon dx square is equal to x upon 1 minus x square raised to power 3 by. तो जैसे अभी हमने किया था बिल्कुल उसी पैटर्न पे क्वेश्चन है, तो प्रूफ. बट यहाँ पर क्या है, हमें टारगेट दिया और कि हमें कहाँ तक पहुँचना है. सो गिवन y is equal to sine inverse x. Since we need to find double derivative, so first we need to find the derivative of this function with respect to x. So this gives you dy upon dx is equal to d by dx of sine inverse of x. और sine inverse x की डिफरेंशिएशन क्या होती है? 1 upon square root of 1 minus x square, जिसको हम कैसा लिख सकते हैं? 1 minus x square raised to power minus 1 by 2. Now, for finding the double derivative, again differentiate both sides with respect to x. This gives you d by dx of dy upon dx is equal to d by dx of 1 minus x square raised to power minus 1 by 2. The left hand side becomes d2y upon dx square. Right hand side पे हम x raised to power n का फॉर्मूला अप्लाई करेंगे, which becomes n into x raised to power n minus 1. Since I am taking this as x but it is not x, तो इसलिए इसको फिर से differentiate, that means chain rule, which is equal to d2y upon dx square minus 1 by 2 1 minus x square raised to power minus 3 upon 2. 1 का डेरिवेटिव आ गया 0, x स्क्वायर की डिफरेंशिएशन 2x. अब पावर नेगेटिव है तो इसको हम डिनोमिनेटर में ले जा सकते हैं. So it becomes 1 minus x square raised to power 3 by 2 into this 2, then minus 1 into minus 2x. 2 और 2 कैंसिल, तो फाइनली हमारे पास क्या बन जाएगा? हेंस actually again just see, this is x raised to power n form, so it is n into 1 minus x square raised to power n minus 1 into d by dx of internal term, that is by chain rule, which is equal to minus 1 by 2 into 1 minus x square raised to power minus 3 by 2 into derivative of 1 is 0 and derivative of x square is 2x. Let's simplify this one. This becomes d2y upon dx square is equal to minus 1 by 2 into 1 upon 1 minus x square raised to power 3 by 2 into minus 2x. So 2 and 2 cancelled. So finally we are left with d2y upon dx square is equal to x upon 1 minus x square raised to power 3/2, जो हमें प्रूव करना था। आप देख सकते हैं d2y upon dx square is equal to x upon 1 minus x square raised to power 3/2. So after this question we have another one. Question is, if y is equal to 2 sine of x plus 3 cos of x, then show that d2y upon dx square plus y is equal to 0. That is a very simple question. Proof: y is equal to 2 sine of x plus 3 cos of x. For reference, I am taking this as first. Differentiate both sides with respect to x, which gives you dy upon dx is equal to d by dx of 2 sine of x plus 3 cos of x. We know that derivative of sine is cos, so it is equal to 2 cos of x minus 3 sine of x, as derivative of cos x is minus sine of x. Again differentiate both sides with respect to x, क्योंकि हमें d2y upon dx स्क्वायर चाहिए। तो हमारे पास लेफ्ट हैंड साइड पे क्या बना, dy dx of dy upon dx is equal to dy dx of 2 cos of x minus 3 sin of x. It simplifies to d2y upon dx square is equal to cos की डिफरेंशिएशन माइनस साइन और साइन की डिफरेंशिएशन cos of x। अगर आप इन दोनों टर्म्स में से माइनस कॉमन लें तो हमारे पास क्या आ जाए, 2 साइन ऑफ x प्लस 3 cos of x। और अगर आप इस टर्म को कंपेयर करें फर्स्ट के साथ, इट इज नथिंग बट y। सो आई कैन राइट d2y upon dx square is equal to minus y. This is from first, and this proves your question. Hence, d2y upon dx square plus y is equal to 0. Let's take the another one. Question is, if e raised to power y into x plus 1 equals to 1, then show that d2y upon dx square is equal to dy upon dx whole square. Even you can go directly, you can directly differentiate this one, then find the derivative dy by dx. Whatsoever you will get, you again differentiate with respect to x and get d2y upon dx square. Then on comparing d2y upon dx square and dy upon dx, you can reduce whatever is required. But let's do it in another way. We are given that e raised to power y into x plus 1 is equal to 1, which can be written as e raised to power y is equal to 1 upon x plus 1. Apply log to the base e, then it is log of e raised to power y is equal to log of x plus 1 raised to power minus 1, because we can write this as x plus 1 raised to power minus 1. Now this is log m raised to power n, so it is y log of e is equal to minus times log of x plus 1. as we know that log e is equal to 1, so we have y is equal to minus times log of x plus 1. So here we have this one. Differentiate both sides, which gives you dy upon dx equals to minus times d by dx of log of x plus 1, which gives you dy upon dx is equal to minus 1 upon x plus 1 into d by dx of x plus 1. That means dy upon dx is equal to minus times 1 upon x plus 1. For reference, I'm taking this as first. Now, again differentiate both sides with respect to x, which gives you d by dx of dy upon dx is equal to minus times d by dx of, I can write that as x plus 1 raised to power minus 1. So left hand side is d2y upon dx square is equal to minus times derivative of this term is minus 1 into x plus 1 raised to power minus 1 into d by dx of x plus 1, which gives you d2y upon dx square is equal to minus into minus plus, so it is x plus 1 raised to power minus 2, which is nothing but 1 upon x plus 1 whole power 2. Now I'm taking this equation as second. If you compare first and second, from first and second, what we have d2y upon dx raised to power 2. If you square this term, you are going to get this one. So this is equal to dy upon dx whole square, which is result. Let's move on to another problem. This time we are having question, if y is equal to sine inverse x, then show that 1 minus x square into y2 minus x into y1. पहले भी हमने एक ऐसा क्वेश्चन लिया था, ये बिल्कुल वैसा ही है. Then proof, we are given that y is equal to sine inverse of x. Since y2 means d2y upon dx square and y1 means dy upon dx, तो हमें यहाँ पर dy by dx और d2y upon dx square का वैल्यू डिटरमाइन करना है. उसके लिए डिफरेंशिएट बोथ साइड्स, which gives you dy upon dx is equal to d by dx of sine inverse of x. dy by dx means y1 is equal to sine inverse x का differentiation 1 upon square root of 1 minus x square. So squaring both sides, on squaring both sides what we get, y1 whole power 2 is equal to 1 upon 1 minus x. मैं इसको भी ट्रांसपोज कर देता हूँ लेफ्ट हैंड साइड पे, मेरे पास क्या आ जाए 1 minus x square into y1 power 2 is equal to 1. Again differentiate both sides with respect to x. तो ये d by dx of 1 minus x square into y1 का square is equal to d by dx of 1. यहाँ पर दो टर्म्स मल्टीप्लाई करें तो वी आर मेकिंग यूज ऑफ प्रोडक्ट रूल 1 minus x square into d by dx of y1 whole power 2 plus y1 whole power 2 into d by dx of 1 minus x square और 1 की differentiation 0. Now this is of the kind x raised to power n. It is 1 minus x square into 2 times y1 into d by dx of y plus y1 square into 1 का differentiation 0 और x square का differentiation minus 2x equals to 0. अगर आप इन टर्म्स पे ध्यान दें तो 2 times y1 और 2 you can take common. तो ब्रैकेट में हमारे पास क्या आ गया 1 minus x square y1 की differentiation is y2. यहाँ से y1 आपने कॉमन ले लिया तो एक y1 आपके पास बच जाएगा 2 आपने कॉमन ले लिया तो माइनस x is equal to 0. This implies 1 minus x square into y2 minus x into y1 equals to 0 because y1 is not equal to 0 as y1 was this term. So this proves question. बट इस क्वेश्चन को करने का एक और तरीका है कि जैसे यहाँ पर मैंने लिखा y1 और y2 तो आप y1 तो हमने फाइंड किया हुआ है आप यहाँ से y2 भी फाइंड कर सकते हो y1 is 1 upon square root of 1 minus x square तो y2 is equal to d by dx of y1. This is another way of solving the same problem which is equal to d by dx of 1 upon square root of 1 minus x square. That means y2 is equal to d by dx of 1 minus x square raised to power minus 1 by 2 which is equal to minus 1 by 2 into 1 minus x square raised to power minus 1 by 2 minus 1 into d by dx of 1 minus x square which gives you y2 is equal to minus 1 by 2 1 minus x square raised to power minus 3 by 2 into minus 2x. 2 will cancel 2 that means y2 will be equal to x into 1 minus x square raised to power 3 by 2. ये हमारे पास आ गया वैल्यू इसका y2 का. चलिए शाबाश. अब प्रूफ क्या करना तो उसकी लेफ्ट हैंड साइड को कंसीडर कीजिए. कंसीडर 1 minus x square into y2 minus x into y1. 1 minus x square y2 का वैल्यू आपने क्या निकाला था x into 1 minus x square raised to power minus 3 by 2 minus x y1 का वैल्यू था 1 upon square root of 1 minus x square. So what we get, these two terms they have same basis so their powers will be added. It is x into 1 minus x square raised to power 1 minus 3 by 2 minus x. I can take this term into the numerator 1 minus x square raised to power minus 1 by 2 which equals to x into 1 minus x square raised to power minus 1 by 2 x 1 minus x square to a minus 1 by 2 since terms are equal so their difference is equal to 0. Hence what we get 1 minus x square into y2 minus x into y1 equals to 0. This is another way to solve the same problem. Now this is very important question. काफी बार एक CBSE बोर्ड एग्जाम में पूछा गया है. तो क्वेश्चन क्या है? If x is equal to a into cos theta plus theta sin theta and y is equal to a sin theta minus theta cos theta, then find d2y upon dx cube. Solution. We are given that x is equal to a cos theta plus theta sin theta. Y is equal to a sin theta minus theta cos theta. मैंने आपको बताया था कि जब भी हमारे पास दो डिफरेंट वेरिएबल्स आर एक्सप्रेस्ड इन टर्म्स ऑफ अ सिंगल वेरिएबल, then those two equations are called as parametric equations. तो अभी हमारे यहाँ पर दो पैरामीट्रिक इक्वेशंस दिए गए हैं और पैरामीटर हमारे पास थीटा है और हमें फाइंड करना है डी टू वाई अपॉन डी एक्स स्क्वायर। तो हम पैरामीट्रिक इक्वेशंस की हेल्प से डी वाई बाई डी एक्स फाइंड करेंगे, फिर से उसको डिफरेंशिएट करेंगे। तो डिफरेंशिएट बोथ साइड्स विद रिस्पेक्ट टू थीटा। सो मेरे पास डी एक्स अपॉन डी थीटा is equal to a into d by d theta of cos theta plus theta sin theta और simultaneously मैं dy by d theta भी फाइंड कर लूँ। This is equal to a into d by d theta of sin theta minus theta cos theta. So dx upon d theta will be equal to a into cos theta का डिफरेंशिएशन माइनस sin theta, यहाँ पर दो टर्म्स की मल्टीप्लिकेशन है तो प्रोडक्ट रूल अप्लाई हो जाएगा, प्लस थीटा इंटू d by d theta of sin theta plus sin theta into d theta by d theta और सेम dy by d theta के लिए which is equal to a sin theta की डिफरेंशिएशन cos theta, यहाँ पर भी दो टर्म्स का मल्टीप्लिकेशन है तो प्रोडक्ट रूल, सो माइनस थीटा इंटू डी बाई डी थीटा cos theta प्लस cos theta इंटू d theta by d theta। चलिए सिंप्लीफाई करते हैं। dx अपॉन d theta इसके इक्वल हो जाएगा a minus sin theta plus theta cos theta and plus sin of theta. If you look at these two terms, they are equal and opposite in sign. So this gives you dx upon d theta is equal to a theta cos theta. चलिए जी, रेफरेंस के लिए हम इसको बॉक्स में रख रहे हैं। इसी तरह से dy by d theta की सिंप्लीफिकेशन क्या हो जाएगी, is equal to a cos theta, इस माइनस के कारण what we have theta into cos theta की differentiation minus sin theta, then again because of minus sign becomes cos of theta, again cos theta and cos theta they are cancelled out, so dy upon d theta will be equal to a theta into sin theta. So this is dy by d theta and we have dx by d theta by chain rule. Dy upon dx is equal to dy by d theta divided by dx by d theta, which is equal to a theta sin theta upon a theta cos theta, which is equal to tan of theta. चलिए हमारे पास dy by dx आ गया, dy by dx is tan theta, लेकिन हमें फाइंड क्या करना है d2y upon dx क्यूब, तो अगेन डिफरेंशिएट both sides with respect to x, which gives you d by dx of dy upon dx is equal to d by dx of tan theta, which is equal to d2y upon dx square is equal to tan theta की differentiation secant square theta into d theta upon dx, और d theta upon dx हम कहाँ से लेके आएंगे, from this equation. For reference I'm taking this as first, तो dx upon d theta is equal to a theta cos theta, तो d theta upon dx किसके इक्वल हो जाए, इसका रेसिप्रोकल, So it is equal to secant square theta into 1 upon a theta into cos theta. जब ये cos theta न्यूमरेटर में जाएगा तो आपके पास क्या आ जाएगा, is equal to secant cube theta upon a theta. This is our final answer. लेकिन जनरली जब ये बोर्ड एग्जाम में आता है तो बच्चे उसको गड़बड़ कर देते हैं, और गड़बड़ क्या करते हैं वो भी आपको बताते हैं। यहाँ पर dx upon d theta, what they used to find, d2x upon d theta square, यानी कि इसको विद रिस्पेक्ट टू थीटा डिफरेंशिएट करते हैं। और इसी तरह से d2y upon d theta square which is equal to a थीटा साइन थीटा का डेरिवेटिव, और उसके बाद चेन रूल अप्लाई करके लिख देते हैं डायरेक्टली d2y upon dx square is equal to d2y upon d theta square upon d2x upon d theta square। अगर आप यहाँ पर ध्यान दें तो दिस इज d2y upon d2x which is incorrect। और अगर आप ऐसा करके आते हो तो आपको बस इस स्टेप तक के ही मार्क्स मिलेंगे, बाकी सब आपका इनकरेक्ट हो जाएगा। करना क्या है, आपने डी एक्स अपॉन डी थीटा निकाला, डी वाई अपॉन डी थीटा निकाला, चेन रूल से डी वाई अपॉन डी एक्स निकालिए, जो आएगा डी वाई बाई डी एक्स उसको फिर से डिफ्रेंशिएट कीजिए विद रिस्पेक्ट टू एक्स, तो आपके पास डी बाई डी एक्स ऑफ tan थीटा आ जाएगा विच इज सीकेंड स्क्वायर थीटा, क्योंकि हम विद रिस्पेक्ट टू एक्स कर रहे हैं तो इनटू डी थीटा अपॉन डी एक्स, जिसकी वैल्यू हम इस एक्सप्रेशन से लेके आएंगे और सिंप्लीफाई करेंगे, तो आपके पास फाइनल आंसर जो होगा दैट इज सीकेंड क्यूब थीटा अपॉन ए थीटा। तो इस तरह से आप बाकी क्वेश्चंस जो हैं इस टाइप के आप सॉल्व कर सकते हो, प्रैक्टिस कर सकते हो। तो हम ये वीडियो अपनी यहीं पे कंक्लूड करते हैं। नेक्स्ट वीडियो तक कीप प्रैक्टिसिंग, बिकॉज मैथमेटिक्स विदाउट प्रैक्टिस इज मीनिंगलेस। जितना प्रैक्टिस करोगे उतना ही आपका कंफर्टेबल फील करोगे और मजा आएगा। थैंक यू।